So I will start my talk by showing you this image that I first saw in a National Geographic article. Typically, people would say, wow, that's so cute, but I'm a veterinary cardiologist with a background in engineering who is obsessed with the heart, since the heart really is the most perfectly designed pump made by nature, and even engineers cannot recreate. And unfortunately, my reaction is, oh, this little dog is going to get mitral valve disease. In fact, I tell my students that if you can pick up a dog with one arm, then that dog is going to get mitral valve disease. Somehow in the process of shrinking the size of a dog, we have inadvertently introduced this heart valve disease to the little guys. And at this point, you're probably wondering, what is this mitral valve disease she keeps talking about? So this is an aging disease where as our dogs get older, for some unknown reason, the main heart valve starts to deform and leak. To put it in perspective, imagine that your basement water pump springs a leak and it's no longer pumping water effectively. And in fact, you're going to have a bad flood in your basement. So the same thing happens to the heart, except now the flooding is in your lungs and no one can breathe well when there's flooding in the lungs. Unfortunately, there's no cure for this disease and we only have medication to manage the flood. It's a terrible conversation I have to have with dog owners over and over again, telling them I have nothing for them and I can only buy them some time. So this is the motivation for my research. I want to find out why the heart valve starts deforming so we can prevent it from happening. Right now, no one's been able to figure out which specific gene is at the root of the problem, which makes us think if it's not actually the fault of one gene, but perhaps how it's being controlled. And this is a unique perspective that my research is taking on our investigation. One ubiquitous gene regulator called microRNA can decide which gene to translate into actual biological function and which ones to ignore. So it becomes a problem when the microRNA is dysfunctional and starts to read out the bad genes while ignoring the good ones, and then you end up with deformed mitral valve. You can also imagine that if we can identify which microRNA has gone rogue and block it, we can prevent mitral valve disease in dogs. And this is what my research lab is trying to do. And you'll hear a lot more about genes in the next talk by Dr. Heather Gardner. As it turns out, the same mitral valve disease happen in people. Their advantage is that they have open heart surgery to fix a valve. Yet we all know that healthcare is more efficient with disease prevention rather than expensive treatment. So just like us, human cardiologists are also working towards understanding the cause of this valve disease. My lab has therefore partnered with scientists studying the human condition, sharing information to identify specific microRNA involved in the mitral valve disease. And this is a one-held concept that, again, you'll hear about in later talks. I am sharing my next slide again to let you know that I have not forgotten about our big dogs in my research. Unfortunately, a lot of our big dogs end up with cancer. As a cardiologist, I get involved when the cancer treatment ends up hurting the heart. This is such a common problem. For example, in people, second to recurrence of cancer, heart disease is the most common cause of death or poor quality of life in cancer survivors. Heart injuries from cancer treatment has become such an important problem that in human hospitals, they have created a new discipline called cardio-oncology. And just like their human counterparts, our pet dogs are treated with the same cancer drugs. So not unexpectedly, they can also develop heart problems after cancer treatment. It is extremely frustrating when you finally conquered cancer and now you're dealing with heart disease because of your treatment. So my research lab, together with researchers, clinicians at Tufts Medical Center, and our own oncologists, want to better understand how these heart injuries occur so we can prevent it, to develop new imaging technique or markers to detect injury sooner so that damages can be reversed, and to find drugs that can prevent injuries from happening in the first place. Our common goal is to give cancer survivors, whether human, dogs, or cat, the chance for a quality of life they have fought for so bravely. Thank you very much.